It is week 5, and this is Introduction to Networks. It's Monday, February 10th. First thing they did, all the students were to email me their grade. I wanted to make sure they know what their grade is and how did they achieve that grade. Okay? Good or bad or whatever. How did they end up with that grade? What caused them to get that grade? We talked about number systems today. We did some switch configurations and we took an assessment. Let's take a look at some of those items. We reviewed the OSI model. Briefly, we talked about the physical layer. The physical layer puts the bits on the medium, wire, electricity, fiber, light, and then some type of radio waves for wireless or microwaves. Where did the word bits come from? It's a binary digit, base 2. And we'll talk more about that later. Up here, we had an IP address that we're referring to. Actually, we were working on DNS, and Zach, I believe, gave me the addresses. 172.31.02, 172.31.05, 172.31.01. I believe this is a standalone machine. These are virtual machines. That's a V. Doesn't look like it. VMs. And this is an IP4 address. It's made up of 32 bits, and it's a dotted decimal. Okay, here's 8 bits, a dot, 31 represents 8 bits, 0 represents 8 bits, and the 2 represents 8 bits. That's where those 8s come from up here. So, decimal is base 10. We use the digits 0 through 9. 10 digits to represent numbers. And then it's grouped. Like this 172, that's one group of 100. 10 squared is 100. 7 groups of 10. 10 to the first 10. And 10 to the 0, anything to 0 is 1. And so 2 groups of 1. 172. Now we're going to later on compare that to base 2. Now, this whole idea of DNS, we have, first of all, we have multiple ones, so if one's down, we can use the other. Or we can have DNS out from the cloud. Cloudflare has a DNS server you can get DNS from, and also we'll talk a little bit more about Google and so forth. 13 major DNS servers out in the internet, and that DNS is funneled down to these other ones. Not all of it, just what you need. So it makes more sense to access our DNS server to get an IP address for a domain name rather than have this traffic going in and out through the internet to get those. And then these DNS servers can act as an intermediate, if you want to think of it that way. We talked a little bit about our configurations down here. We've got the firewall, and then we have the DMZ, and these PCs are the Linux PCs. And then we have the other switch, in which we have our regular PCs on those. They're connected to the multi-layer switch. The DMZ goes straight to the firewall. And we're going to look at this more on Wednesday. We'll look at this topology. Alright, so we will look at, am I going here? Yeah. We will look at our topology. We'll take a closer look at that on Wednesday. Okay. And then here you can further see where we talked about Google's DNS, Cloudflare, DNS, local DNS, and then like if you were at home, your DNS is going to be supplied by your ISP would have DNS servers. So if you looked at, you know, your computer would show your little router as your DNS, but it would be getting it from the ISP. Addressing. So we took a look at base 2. Remember, base 10, 10 digits. Base 2, we have 2 digits. Binary, 1 and 0. So that's where 2 to the 0 is 1, and this is 2, and I wrote them up here. So if you want to see them up here. So that one's 1, it's 2, 4, 8, 16. 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128. So if we want to convert this binary number to a decimal number, this is how we do it. We have one group of 128, one group of 16, see where I got it up there, right up there, and one group of 8, and here's the other one groups of 1. Add them together and get 147, if I added that right. Yep. Now if you want to go the other way, you want to convert 172 back to binary like we did here in class. We took 172 and we took one group of 128, so that was this one. Then we subtracted that, and now we have 44 left. You can't take a 64, right? But you can take a 32. So then we took 32 out of there, and that's this one group of 32. Then we ended up with 12, and this is one group of 8 and one group of 4. 8, 9, 10, 11, 12. So this is the binary representation. And then we could do the same for 21. Let's do that one. So 1, 2, 3, 4, 5, 6, 7, 8. So 21, if I was to write that down, we have no groups of 128, no groups of 64, no groups of 32, one group of 16, so where's that, 5? We wanted to make that 11, so now we have 5, and so 0 groups of 8, one group of 4, and one group of 1. Now, we did talk about, I'll just mention this briefly, /16. So what the router does, that means this is the prefix. So it takes these ones and matches them up here. And if it's a 1 and a 1, it's a 1. If it's a 1 and a 0, it's a 0. So then it gets the network address. And it ignores all these, which would be the host or the interface. One more thing to cover. MAC address, 48 bits. If you look at a MAC address, one of the students gave me theirs, 48 bits, so we usually represent that as a hexadecimal. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 groups of 4, 48. Hexadecimal uses 16 digits. So you say, which one, how does it do that? Well, it uses 0 through 9, and then 10 is an A, 11 is a B, 12 is a C, 13 is a D, 14 is an E, and 15 is an F. And that's why in the MAC address you get this variation. Excuse me. Alright, so if I was to take a look at that then, this 4, then to get 16, you can use 4 bits to represent all these combinations of 16. So an easy way when you're working with a MAC address to convert it to decimal, or excuse me, binary is the easiest thing to do first. So that's a 4, so you just use 4 bits to represent that 4. So 2 to the 0, 2 to the first, 2 to the second, 2 to the third. So that's, 8, 4, 2, 1. So one group here would represent a 4. Now an A here is like a 10. So we have one group of 8, one group of 2. If you look back at our example here. That is a 15, so that would be one group of 8, 4, it'd be 12, 13, 14, 15. And so then you could go through and convert all these to ones and zeros. That if you had it converted to, we'll talk later on about converting it to decimal. That is it for today.